Okay, in this video we are going to talk about numerical methods for summarizing data sets. Pick just a simple data set. Say you have a sample of 50 grades for students that you collect at random from around campus for a math course, and you want to summarize it. How would you summarize that data? What you would be looking for to summarize it? So in the previous video we talked about how we summarize the data graphically, but today we're going to talk about how do we summarize the data numerically. There are two things we want to get to summarize the data. One is a measure, we call it a measure of central tendency, and everybody is familiar with the mean. So we want to get the mean for the data, but there are other ways of calculating a central measure, like the median and the mode. So we're going to describe how we can get all of these. But also we want data can be data sets, all the numbers can be very close to each other or they can be far apart, and how do we measure their relative position to each other? And that we call that the measures of dispersion or measures of variability. And we have the range, mean absolute deviation. Some books don't have that, but really this is very useful in understanding the concept of the variance, which we're going to talk about, and the standard deviation. So we're going to talk about the measures of central tendency, which is the mean, median, and mode. We're going to start with those, and we're going to start with a sample. Suppose now we have a sample, say whatever measurements, but we going to represent them with symbols. So we're going to represent sample in this way. So it's x1 my first measurement, x2 my second measurement, and so on. xn is my nth measurement. So my sample size is n. So I have n of these. I have the definitions here. N is the sample size, and x sub I is the value of the ith observation in the sample. So we start, how do we calculate the sample mean? And that's very simple. Still we're going to go over that, or sometimes called the arithmetic average. Now we use the notation x bar for that, and to calculate that sample mean we add all the measurements. So we had x1, x2, xn, we add them up all together, we divide by n. When you add values like these, since we have three dots, it's not a good notation. Sometimes we have used this summation notation. So this is the Greek letter for S, stands for summation, which means sum all the x, the values you have, and then divide by n. Here's an example. So suppose you have a small sample. I'll illustrate these ideas with small samples, but because they extend to large samples. So I have 5 test grades. I have 90, 95, 80, 60, and 75. To obtain the sample mean, just add them up together. So that's the symbol for adding up all the measurements, which is the numerator here. X 90, 95, 80, 60, and 75. So I get 400. Then I use my formula, and remember you always have to use the formula to do that. So this is my formula here. So first you write down the formula, then you substitute. The numerator is 400 from here up there, and n is 5, so that's equal to 80. And because the same thing here, we have x now is the age. So we have ages of how many here? 6 students. So we get a sample of 6 measurements. So we get the total, we divide by 6, and we get the average. Second method is called the median. to find the median. And in this case, the median of a data set is really the middle numbers when you arrange those values in ascending order. So what does that mean? Let's illustrate that by again using an example. So if n is odd, the median will be exactly the middle number. But if the sample size is even, you have two middle numbers, so you're going to get the average of these two. So suppose I have a sample with these measurements, 5 of them. They are 9, 2, 7, 11, and 14. First, I arrange them in ascending order. So the 2, 7, 9, 11, 14. And this is my middle number, which is my median. The sample, here's another sample, which I have now 6. So I arrange them in ascending order. I get 2, 6, 7, 9, 11, and 14. And now I have two middle values. So I got 7 plus 9 over 2. I got an 8 as my median. So now let's compare both the mean and the median. One thing we notice about X bar, it's sensitive to extreme values. So in my sample, if I had, say, just think of it as measurements here, and instead of 60 I had a 0 on this test, then my average would go down because of that value. So that value would push my grade down here, and while the median would not be affected. So X bar is sensitive to extreme value. The median is not sensitive to extreme value because we're just taking the measurements and taking the middle value. And so if we have a data set which has all their values are close to each other, but we have few that are far apart, we call that a skewed data set. A better way to measure the average is the median, while if the data is bell-shaped, symmetric, the better way we can use the sample mean. We'll talk more about this later. The mode is another way of measuring the sample average, which is usually the value that occurs the most frequently. That's simple. So if I have a set of measurements like this, I notice that 9 occurs once, 2 occurs twice, 7 occurs, here it is, 3 times, 11 and 14 occur each one. So my mode is 7 because it occurs with the highest frequency. So now, how do I figure out the relative positions of the mean, median, and the mode on a frequency distribution? So if the mean equals the median, then we have a symmetric distribution. If the mean, or this should be greater than the median, then we have a distribution that's skewed to the right or positively skewed. I'm going to graph these in a minute. If the median is less than, if the mean is less than the median, now we have a distribution that's skewed to the left. So for the first one, if I have a shape that's more like this, I'm using a mouse, so it's not easy to do graphs with a mouse. Oops, didn't extend well. And you have a bell shape, that would be the mean and the median would always be fall here. If I have a shape which is the mean is more than the median, so my data would probably look something like this. Again, excuse my shapes because it's using the mouse here. And So in this case, the median is going to be in the middle, where half the measurements are below it, the other half is above it, but the mean is going to be way up there because it's going to be affected both by those large values here. And in the third case, probably have a shape that would go up like this and go down like this. So it would be skewed, negatively skewed, where the median would be here because that's half the area is here, half there, that's divided. So your median would be somewhere here, while oops, I don't need that. While the mean would be low, much lower than that down here, because it gets affected by those small values since we average all values. Okay. So in the next video we'll talk about measures of variability, and basically measures of variability is we're going to look at how are these values going to be distributed. Are they distributed close to each other, something like this, or are they distributed far from each other, where you have a graph like this, and how do we measure that variability in the data? All right, thank you.